is 1, the output sum is 1 and the carry is 0, and for input A is 1 and B is 0, the result is same, that is sum is 1 and the output carry is 0, and for both input 1 the carry is 1 and the sum is 0. Let me discuss it. Let me discuss full ladder. Here we have full ladder. We can see that when the all inputs are 0, and it is A, B, and the carry in our output sum and carry out is also 0, and for carry in 1, for the input carry in 1, our output sum is 1 and the carry out 0, and for B is 1 and the carry input and A is 0, the output sum is also 0, sorry, the output sum is 1 and the carry out is 0. And for input 1B and carry input is 1, the carry output is 1, and the output sum is 0, and for only A is 1 and other inputs are 0, the sum is 1 and the carry output is 0, and for A and carry input is 1, we can see that the carry output is 1 and the sum is 0, and for A and B is 1, when A and B is 1 and the carry input is 0 and the carry output is 1 and the sum is 0, and when all inputs are 1, our all outputs are 1, it's sum and where output is 1. Now move on to the half subtractor. This is a truth table of half subtractor, and this is circuit implementation of half subtractor. When all the inputs are 0, we can see that the difference and the borrow is also 0. The difference and the borrow is output, and when Y input is 1, the difference is 1 and borrow is also 1, and when X is 1 and Y is 0, and the difference is 1 and the borrow is 0, and when all the inputs are 1, we have 0 output, and that the difference and the borrow is 0. Now move on to the full subtractor, and this is the truth table of full subtractor, and this is circuit implementation of full subtractor. When all the inputs are 0, our output, that is difference and borrow, is 0, and when the Z input is 1, the difference and borrow output is also 1, and when the Y input is 1 and the others all are 0, the difference and borrow are also 1, and when Y and Z are 1 and the borrow is 1 and the difference is 0, we can check it from the truth table, and when X is 1 and all the other inputs are 0, the difference is 1 and the borrow output is 0, and when X input and Z input are 1, you can see that there is 0 output, and when X and Y input are 1 and Z input 0, the output is also 0, and when all the inputs are 1, we have one input, add difference and borrow. Now we move on to the adder subtractor. Here is the 4-bit adder subtractor. From here we can see that this is addition and this is subtraction. This 0, 0, 0, 1 is the binary numbers, and its equivalent decimal number is 1, and 0, 0, 1, 0 is also a binary number, and its equivalent decimal number is 2. As we are performing addition here, perform addition, the operations must be 0. You can see that for first input it is 0, 0, 0, 1. We set it to 0, 0, 0, 1, and for other input it is 0, 0, 1, 0, 0, 0, 1, 0. Can see that here is the R1 and the R0 are below, that is, it is 1. Can check it from the truth table. So the result R1 and the result R0 are below, and the other result are 0. And the result is showing in binary numbers, and its equivalent number is 3. Let's discuss it for subtraction. To perform subtraction, we put it to 0, to put the operation to 1, the controller to 1. Here we can see that 1, 0, 0, 0 and 0, 1, 0, 1, and their equivalent decimal numbers are shown to the right. 1, 0, 0, 0, set it in the 1, 0, 0, 0, and 0, 1, 0, 1, 0, 1, and then 0, 1. And see it again, the R0 and R1 are blowing, and the O is also blowing. Here the R1 and the R0 are blowing, and since it is fraction and its decimal equivalent number is 3. So this is the implementation of all the binary circuits. Thank you.